We all know that the Matrix is not exactly the most reliable source when it comes to accurately portraying real-life physics, but is any of what we see on screen feasible at all? That's what I want to find out, so let's get started. In this to save his leader Morpheus, who was captured by the military in order to be turned. Neo could not let that happen. He plugs himself back into the train track, then jumps on with him. Little did he know that a train was coming their way at full speed, and Neo managed to backflip onto the side rail just in time for the train to barely miss him. In this scene specifically, I'll be analyzing the Matrix's connection to our kinematics, dynamics, and energy units to finally answer the question, is that really possible? Neo, in this case, is our object. We know that he starts out at rest, then is picked up and thrown, meaning his initial velocity is 0. However, the moment Neo is picked up by Agent Smith, he has a non-zero velocity, and Agent Smith does work on the object, Neo, using his energy to throw him and turning his potential energy into kinetic energy. When he is thrown, he starts at a relatively low, constant velocity and continues to accelerate at a constant rate until he hits a wall, at which point the wall will react with an equal and opposite reaction, as described by Newton's third law, sending him into free fall until he hits the track. As the train approaches him, he uses a considerable amount of force, energy, and power to backflip onto the side rail. And the subway is seen to be moving at a constant speed towards where Neo and Agent Smith are standing. There were no clues besides that the train is estimated to be 2 widths away, or 2.9 meters from the agent. And to find velocity, I used the average speed of a subway in Australia, which ended up being around 100 kilometers per hour, 27.8 meters per second. Now, the time Neo has to escape can be calculated using the simple formula V equals delta D over delta T. Doing the calculations, I get 0.1 seconds. Of course, this was slowed down for dramatic effect in the movie, so the real time using a stopwatch is around 23 seconds. But if this situation were to happen to someone in real life, whoever's stuck there better duck, otherwise it'd end up like Agent Smith here, since the average human reaction time is 0.25 seconds, and even with training, it's 0.19 to 0.2 seconds. So now we know for sure that no one would stand a chance at escaping that train in time. Except Neo, of course, because he's the star of an action sci-fi film where the laws of physics don't seem to apply. But would the train have been able to safely stop in time? In this situation, the coefficient of friction of the subway wheels on the track, as well as the train's mass, can be researched. It turns out that the average passenger subway weighs 37,195 kilograms, and its coefficient of friction on the track is 0.5. Using this, we can apply Newton's second law and 2 other kinematics equations to determine the distance needed for the train to safely come to a stop. Using the calculations shown right here, it would take almost 79 meters after the driver sees Neo and Agent Smith to stop. As stated before, the proportions shown in the movie indicate that the train was maybe 2.9 meters away when the driver saw them. That's not even close. So unless Superman comes to save the day, saying that the subway had enough time to avoid hitting them is unrealistic. That's something the Matrix got right. Another important connection to physics that can be analyzed here is the application of Newton's third law of motion. Newton's third law states that every actional force has an equal and opposite reaction. For example, you are exerting a force downward onto your chair, so the chair reacts by exerting the same amount of force up towards you, maintaining a balance. Similarly, when Neo slams into the wall, he exerts a specific amount of force in the wall, and in return the wall reacts with the same amount of force back on him, or at least it's supposed to. If the wall fails to react with the same amount of force on the object, the material breaks. This is precisely what seems to happen in this scene, which means this part is accurate. Okay, now the last thing I'm going to discuss before moving on to our final unit, energy, is the force acting on Neo as he slams against the wall. To calculate this, I could simply employ Newton's second law, which states that the net force acting on an object is equal to the mass of the object multiplied by its acceleration. F net equals ma. Doing the calculations, I concluded that 656 newtons of force was acting on him on impact with the wall. That's equivalent to having a 147 pound or 67 kilogram amount of force on someone. That's like having a 70 kilogram cheetah on your chest. More than enough to cause at least some damage. In terms of the energy in this scene, factors such as the amount of work done by Neo, his power, and verifying the law of conservation of energy can be analyzed. Starting with work done, the work done by Neo when jumping to perform the backflip is equal to F delta D cos theta, or the change in potential energy. In this case, I use the change in potential energy, and since it is zero in the end anyways, that means that work can also be expressed as potential energy, mgh. Height was not directly given, but to estimate it, I found that the average subway is 12 feet tall, so a third of that, which is how tall the ledge appeared to be, would be 4 feet, roughly 1.2 meters. So his work done would be 79 times 9.8 times 1.2, which will give 929.04 joules. Subsequently, Neo's power can be determined using the equation P equals W over T. That would be 924.04 divided by 0.1, which would be 9,290 watts of power. The average untrained person can only produce around 100 watts of power, and a fit recreational cyclist can maintain about 200 watts. Not 9,000. So that's not accurate on their part because as far as I'm aware, the actor playing Neo, Keanu Reeves, weighed more than a single feather. Last but not least, I want to see if the Matrix could at least stay consistent with the law of conservation of energy. The law states that energy cannot be created nor destroyed, only transformed. I can do this by calculating Neo's potential energy, then comparing that to his kinetic energy to see if they match up. Neo's potential energy, as stated earlier, is 929.04 joules. That's already given. His kinetic energy can be determined using the formula Ek equals mv squared over 2. This would be 79 times 4.15 squared divided by 2, which gives 680 joules. This leaves about 250 joules of energy missing, part of which may have broken the wall or been lost to air resistance instead. So it seems likely that the law of conservation actually applies here. In conclusion, the Matrix wasn't all wrong about everything, but please don't use it as your physics teacher. Now goodbye.